Hey guys, it's Ms. Fendley. Today we're looking at section 5.2, Congruent Polygons. Our learning objective for this section is to be able to identify and use corresponding parts to name congruent polygons. Congruent figures. So remember, two figures are congruent if a rigid motion or a congruence transformation maps one figure onto the other. So if you can take a shape, move it around by sliding it, flipping it, or turning it to make it lie perfectly on top of another shape, or another figure, then those two figures are congruent, which means they're the same size and the same shape. A rigid motion maps each part of a figure to a corresponding part of its image. Because rigid motions preserve length and angle measure, which means they stay the same size and same shape, then corresponding parts of congruent figures are congruent. And we will talk about what that means in just a minute. In congruent polygons, this means that corresponding sides and the corresponding angles are congruent. So for example, we have triangle ABC. So triangle ABC, and if you took triangle ABC and you could maybe rotate it and flip it around, you would be able to see if I can't flip on here, that's a bummer. But if you rotated it, flipped it around, you can make it lie perfectly on top of triangle DEF. And so what that means is that when you do that, when ABC is perfectly on top of DEF, then angle A would be perfectly on top of angle D. Angle B would be on top of angle E, and C would be on top of F. And you can tell that those are marked with the corresponding congruent symbols. You guys did really, really well on this question on the pretest, so I'm not going to spend too much time here. But corresponding parts of congruent figures are congruent. So because A corresponds to D, A is congruent to D, which means they're the same size. And the same thing goes for the side lengths too, since AB would be on top of DE, then the length of AB is the same as the length of DE. Okay? You guys did really well on this question, or these two questions on the pretest, so you guys get this one pretty well, I think. Corresponding parts of congruent figures are congruent. When you are naming two congruent figures, when you write a congruent statement for two polygons, always list the corresponding vertices in the same order. So for the first triangle, it doesn't matter. I could have said ABC. I could say triangle ABC. Once I have named that first triangle, I have to list my second triangle. Excuse me, that is supposed to be a triangle, not a angle. Triangle ABC. I have to list my second triangle in the same order, since A goes with D, B goes with E, and C goes with F. That would be triangle DEF. I could have said for this first triangle, let's say I could have said BAC. So triangle BAC, because the first triangle I can name in whichever order. But since if I go from BAC, then B goes with E, A goes with D, and C goes with F. So triangle BAC is congruent to triangle EDF. List the corresponding vertices in the same order. Okay? List the corresponding corners or the corresponding vertices in the same order. Okay? So I want you guys to do this. You try. Write a congruent statement for the at the triangles and identify all pairs of congruent corresponding parts. Pause the video and come back to check this when you're done. Okay. Hopefully you've worked this one on your own and you're back to verify. So MN has this, for the congruent sides, MN has 1 dash. So it is congruent to YX, which has 1 dash. NP has 2 dashes. I'm actually going to list this over here, I think, just for the sake of space. NP has 2 dashes. So NP is congruent to XZ, which has 2 dashes. And then side PM has 3. So ZY has 3. Okay? So I'm just grouping them together by their congruence marks. For my angles, I have, for my first triangle, angle M is congruent. Let's see. M has 2 arcs. So Y has 2 arcs. So M is congruent to Y. Angle N has 3 arcs. Angle X has 3 arcs. And angle P has 1 arc. So it is congruent to angle Z with 1 arc. Okay, so we pay attention to our congruence marks to figure out which sides are congruent to which sides and which angles are congruent to which angles. For our congruent statements, for the first triangle, you can name it in whatever order you want. So if I say triangle MNP, so if I say MNP, I have to say YXZ. Okay, corresponding parts go in the corresponding orders. I could have named that first triangle something different. I could have named the first triangle PNM, for example, triangle PNM. When I name the second triangle, P goes with Z, N goes with X, and M goes with Y. So corresponding parts go in the same order. The first triangle you name however you want. The second triangle you're just going to list the points in the same order. And I could have, this is not the only 2 options. I could have said MPN, NMP, NPM. There's a lot of options out there. All right. On this example of using properties of congruent figures to find the values of X and the values of Y. Okay, so I have an X here and here. On this one, where it's in angle P, I would need to know Y in order to solve for X. And since I don't know Y, I'm not going to use that one yet. Okay, I'm going to use, the side MQ, side MQ. Okay, so MQ, that's the first 2 letters of the second congruence, or the second quadrilateral. So it's going to go with the first two letters here. MQ goes with side DE. Okay, those are the same. They are congruent. Okay, so x minus 2 equals 8. So I just add 2 to both sides. So x equals 10. Okay. All right. Once I know what x is, I can use that to find y. Okay? P is the last letter. G is the last letter. So P and G, oops, are going to be congruent. Okay? So 3x plus 2y is going to be equal to 84. We just found out that x was 10, so 3 times 10 plus 2y equals 84, and then that's just an equation that we can solve. 3 times 10 is 30, plus 2y equals 84. Subtract 30 from both sides. So 2y equals 54. So 2y equals 54. Divide both sides by 2, so y equals, is that 27? Let me double check that before we move on. 54 divided by 2 is 27. Awesome. All right. Okay. So x equals 10 and y equals 27 because corresponding parts of congruent figures are congruent. So I use the congruent sides and I use the congruent angles to solve for x and y. All right, so you do this you try, then come back to check your work when you're done. Okay, hopefully you solved, or you paused the video and came back to check. Okay, so to find x is in angle F. 10x plus 65 is an angle F. F is the second letter, so it's going to go with B, the second letter. Also, you know, the two obtuse angles are going to go together. Trying to draw this straight, but it is not wanting to. Oof. Okay. So obtuse angle with obtuse angle, or F and B go together. So to find angle, or to find x, 10x plus 65 equals 135. So I'm going to subtract 65 from both sides. So 10x equals 70. And divide both sides by 10. So x equals 7. All right. Then to find y, y is 4y minus 4 is an angle E. Angle E is the first letter, so it goes with angle A, which is 28. Or you could say the most acute angle, the tiny acute angle goes with the tiny acute angle. Okay? So 4y minus 4 equals 28. Add 4 to both sides. So 4y equals 32. Divide both sides by 4. So y equals 8. All right. So corresponding parts corresponding parts of congruent figures are congruent. Pause the video there if you need more time to check that out. Right. Properties of triangle congruence. Triangle congruence is reflexive, symmetric, and transitive. So what that means, the reflexive property means for any triangle, triangles are congruent to themselves. This would be something that you would see more often when we do proofs. We are skipping proofs for this semester only, not, in life in general, but you guys are getting lucky and not being forced to do proofs. So you might not see these as much, but you need to be generally aware of them. So reflexive property means that triangles are congruent to themselves. The symmetric property means that you can flip the congruent statement. So if triangle ABC is congruent to triangle DEF, then DEF is congruent to ABC. And then the transitive property of equality says if A equals B and B equals C, then A equals C. And that's the same thing with triangle congruence. A is congruent to DF, or if ABC is congruent to DF, and DF is congruent to JKL, then ABC is congruent to JKL. Okay. So, and again, if we're not, with us not doing proofs, you might not see those as much, but you just need to be generally aware of them. All right, the third angles theorem. This one we do use, but it's kind of a common sense one once you see it in action. It says, if two angles from one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if angle A is congruent to angle D and B is congruent to E, then it would follow that C must also be congruent to F. And then when I say that this is kind of common sense, so if I know that angle A is, let's say, 30 degrees and angle B is, actually let's make that 50 degrees. This is 50 degrees and this was 100 degrees. So, these are congruent. That would also be 50 while this is 100. Well, to solve for, the angles of a triangle, I just say that angle A plus angle B plus angle C equals 180. So 50 plus 100 is 150. And 180 minus 150 is 30. So even though it's not written in, angle C would be 30 degrees. And then if I solved this triangle for the other, that's going to also be 30 degrees for the exact same reason. So that's why when I say that this is kind of a common sense one, that if two angles from this triangle are congruent to two angles from this triangle, then the third angles are also congruent. Okay. I think I am going to color those in real fast. Okay. So when it says we're using the third angles theorem, and it asks us to find the measure of angle BDC. So that angle right there. My number one recommendation for a triangle that looks like this is separate them. You have two triangles on top of each other here. Okay? So if you take one triangle, like separate them, draw them separately. Okay? And label them. And I'm just trying to find somewhere they'll fit. So on this first triangle, you had A, C, and D, where angle D was marked as being 30 degrees and it has 2 arcs. A has 1 arc and is 45 degrees. Then we have here C, B, and D. Okay, where C has 2 arcs and B has 1 arc. Notice I'm not marking D on this one because the whole angle BDC is not marked. That's actually what we're looking for, angle BDC. Okay, so here we have one triangle where 2 angles are marked and the third one is not. And then here we have this where none of the angles are labeled with their measures. However, we know that angles A and B are congruent because they each have 1 arc. So angle B is 45 degrees. And then this angle C and this angle D both have 2 arcs. So those 2 angles are congruent, and that's 30 degrees. Okay? So when I'm trying to find the measure of angle BDC, I can say, hey, I know the angles of a triangle add up to 180. So 45 plus 30 is 75. And 180 minus 75 is 105. Okay. So angle BDC is 105 degrees. Okay. The measure of angle BDC is 105 degrees. All right. So on these, it's only confusing because they're stacked on top of each other. So separate them and label what you know. And then defined angle D or angle BDC. All I did was add the 2 known angles together and then subtract that from 180. All right, so you try. We don't have to physically separate these, but remember some things that you learned about triangles in, I don't remember what chapter it was, might have been chapter 1. Remember, vertical angles are congruent. So anytime you have angles across from each other, those are vertical angles, and they are congruent. Okay? All right, so while I'm writing this, pause your video and come back to check your answers. Okay. All right, so it's asking us to find the measure of angle DCN. So this angle right here, okay? So it's not labeled yet, but we have that angles angles S and D are marked as congruent. So if angle S is 68 degrees, angle D is 68 degrees. That's what that, you got matching arcs, 1 arc and 1 arc. Now, even though we don't know what it is right off, we know vertical angles are congruent. So I know those two angles are congruent. Okay. The third angles congruence theorem says if two angles from one triangle are congruent to two angles from another triangle, which is what we have there, then we know the third angles are also congruent. So if angle R is 75 degrees, angle C or angle DCN is also 75 degrees. Okay, so the measure of angle DCN is 75 degrees without us doing a lick of math. All right, well, without us doing any arithmetic. I mean, I guess all of it's math, but you didn't have to add or subtract anything. All right, so that's the third angles theorem. It says if two angles from one triangle are congruent to two angles from another triangle, then you know that the third angles are also congruent. You also got to remember vertical angles are congruent. Can't do brain dumps in geometry. Everything builds on itself. All right. If you have any questions, please let me know. If you get to working on the homework and have any questions on that, make sure you ask, and I will be happy to go over everything with you or anything, whatever you need. All right. See you guys later.